Hope is fine. So for today, I would like to take you through research study designs. There are quite many, but I try to select out the most prevalent or the most used that we are going to discuss today. Okay. So what do we mean by a study design? It's just a systematic approach, and these are just techniques, or it's a plan on how you're going to conduct your research. Okay. For every research, after writing the introduction, writing the problem statement, writing the probably the literature review, then you come to how am I going to conduct my research, and that's the methodology. But in that methodology, we have what we call the research, the study design, and this is an approach. Okay, it's a systematic approach. It is it's a direction. It's a way, a method that you are going to use to conduct your research in order to answer your research question. So we have what we call the analytic and also the descriptive kind of studies. And those two kind of studies, as I discussed earlier on, that descriptive deals with just numerics, like frequencies, percentages. You just describe. You don't analyze. You don't infer association. But for analytical studies, you infer or association, or they infer association. So under descriptive and studies, the research designs that you can use to descriptively uh, approach or conduct research are case series, case reports, and also what we call the community surveys. So case series, it's a cocktail of patients with a similar condition. Okay, so many patients brought together with a similar condition. So you try to descriptively uh, uh, conduct research or study them. Let me give an example of maybe patients with HIV, and then you want to know the age group, you want to know their location in terms of geographical location, you want to know about the age, the weight, okay, the BMI. You want to also understand their intake, okay. So that is a case series. Patients of a common with a common condition that you want to study, okay. So the case reports, which are also descriptive, it's one single case. Okay, you pick out a patient, one patient probably with a condition, and then you study that kind of a patient. So you don't generalize. You just want to study this patient. That is the case report. However, for case series, it's a cocktail. There are so many patients with a common condition. And then if we go to the other arm, which is the analytical studies, we have experimental and non-experimental. You've been hearing about the RCT, the randomized clinical trials, and also the non-randomized clinical trials. So randomized clinical trials. Clinical trials, these are research or designs that enable you to come up with maybe new drugs. Okay, you've heard whereby uh, you want to, researchers want to come up with a new drug. So usually what they do what we call experimental studies. But under these experimental studies, they can either be randomized, whereby the participants that are allocated to the different arm of intervention are randomized. Okay. And there is also experimental design whereby the participants to the different arms of intervention are not randomized. Okay, we shall see it later on as we go down into our slide. And then we have what we call the non-experimental, where we have the cohort study. Cohort studies can either be retrospective or prospective. We have what we call the case cohort. Those ones you will also get to know them today. We also have what we call the case control, and we also have under case control there is one called the nested uh, case controls. We have cross-sectionals under still non-experimental and analytic studies. We also have what we call the quasi-experimental, which are also non-experimental and analytic studies designs. Oh, yes. So let's discuss the experimental study designs. So experimental study designs are they study the effect of intervention. Give an example of drug A and drug B, and then you randomize participants into those arms, either to receive drug A or to receive drug B, and you follow them forward in time to either see whether the disease is either the drug has an impact, has an impact on these participants in the two arms. Okay. So you can give drug A, maybe, let me give an example. Drug A could be maybe paracetamol, Panadol, and then maybe drug B could be cassava. That is a placebo. Then you study them forward in time, and then you see whether these patients don't report maybe the effect of the intervention is relief from headache. So after the intervention, you inquire from the patients whether they had relief from headache. So that is the incidence, or you compare the outcomes in the two arms, those that received the cassava and those that received the paracetamol. So that is, those are experimental studies. However, the difference between the randomized and the non-randomized clinical trials is at the eminence of this study, whether these two arms, the participants in the different arms, whether you are going to randomize them, you're going to pick them randomly, whereby each person has a chance to participate in either of the arm, that is randomization, or you sit down and then you're like, Chimera is going to receive treatment A, and CC is going to receive treatment B. And maybe Munir is going to also go to Chimera, receive also A. So that is non-randomized clinical trials. But for randomized clinical trials, we just put maybe all these participants into, you write all their names. I'm giving you the simplest one. You write all their names, put them in a maybe a bowel, and then you be like, the first two I pick will be going to maybe this arm, okay? Or let me first pick those who are going to get treatment A. So you pick the first 5 pieces of paper, and then you'll be like, now those who are going to treatment B, I'm going to also pick the next 5, those are going to treatment B. So each person had a chance to participate in either of the arms or of the intervention. So clinical trials can be categorized into randomized clinical and non-randomized clinical trials. They can also be categorized into community trials, and they can also be classified as controlled or uncontrolled. So for controlled is when you have a comparison. You have, like the image you're seeing here, we have a comparison. We have B, we have treatment, those that receive treatment A and those that receive treatment B. So we shall compare those two. But however, that is now controlled. For non-controlled, there is no comparator. Okay, you only have one arm receiving that treatment, and then you assess the effect at the end of the time. Okay, so that is the classification I'm talking about. So let's go on. So study design, that is then is still under experimental designs, under RCT and non-RCT. So I don't know whether you can see that diagram very well, that for experimental studies, we study the treatment, and then forward in time, we analyze whether there is an effect in the implementation, okay? If it is a drug, we follow forward in time to see whether this drug has an effect on our participants. So that is the same as the outcome. But for non-experimental studies, we now go retrospective from the effect to assess for what caused this effect. Okay, let me give an example of maybe when you want to study side effects of a drug, and then people present with side effects, or they present with, let me give an example of a rash, and then you want to study whether they were exposed to something. So you study them retrospectively, trying to inquire whether they're exposed to a drug or it's just an allergy. So that one is now non-experimental. Okay. You're trying to go back to see whether there was a cause. Okay. So randomized clinical trials, I've given you an example here that from a population of like 100, whereby you only need 20 participants to participate in a randomized clinical trial. So disease or participants with the disease, that those are the ones with the circle that has the white circle, and the non-diseased with a blue circle. So you see that these participants are all in one basket, either A or B, okay? So they are again assigned to either, these participants again are assigned from the population, are assigned to either treatment A or treatment B. So after assigning them that these participants, some of them will receive A and some will receive B, then you go ahead and then pick from these two bowels. We only need 10 from each bowel. So you pick from this bowel. And when you sit down here, you can see that participants that sample. Oh, I don't know whether you can see it clearly down. Let me put this up. So you can see that under the sample from A, we have 9 blue and 1 white, okay? And sample from B, 2 blue and 8 white. So you really see that we equally gotten participants from each of the bowels to participate in our study. And this was randomized. It was by chance. So every participant here, diseased or non-diseased, had the chance to participate in either of the arms, either arm A or arm B as the intervention. Okay? So this is simply an explanation of what randomization means. Okay. I hope we are together there. So let's look at so that is all about randomized clinical trials. So the non-randomized is the opposite of this, whereby assignment to the different arms, either you're going to receive A or B, is not based on chance. You just select them in any way you want, in a convenient way that feels possible or feels comfortable for you as a researcher. Okay. So let's do cross-sectional studies. So for cross-sectional studies, they're also called prevalence studies, whereby the exposure and the outcome are studied at the same point in time. So there is a selection is based on the inclusion criteria. So when you're selecting participants to a cross-sectional study, you base on your inclusion criteria. The example I want to give you is studying anemia in mothers attending antenatal. Okay, so mothers come and some of them have probably anemia and some don't have anemia. And you want to assess whether these mothers are really taking their iron, okay, or they are taking iron-rich foods. So you sit down and then be like, if it's randomization, or like every mother, every second mother that comes into the unit, I'm going to be asking her about her iron intake and also take blood to see whether she has anemia. So you're studying the outcome, which is anemia, and also the exposure, which is eating iron-rich foods. So you're studying them at the same time. I hope I'm clear on that. So that is what the diagram here shows, that you're studying disease, those who have anemia and those who don't have anemia, and then you're studying to whether they take iron-rich foods or they don't take iron-rich foods, okay? So how about now what we call the case control study design? So case control study design, they compare two groups, a case and the control. So the cases are the ones that have the disease and the controls are the ones that don't have the disease. So this is a study design used to study rare cases or rare diseases. Give an example in outbreaks. Let me give you an example. When you go to a party, a birthday party, maybe mine, which I rarely celebrate, and then after eating, you go back and then you develop stomach upset, okay? So that is an outbreak. Maybe five, 6 people develop what? Stomach upsets. So what happens that is now we can use a case control study. We can get the other people that came to my birthday and never got stomach upsets, and those that have stomach upsets. And then you ask them about their uh, exposure. Okay, so you ask them, which parties did you go to? For that day, I woke up very early in the morning. I went to this party. This is the food I ate. Ayubu's party. Me, I ate kalo. I ate beans. I ate meat. I ate chicken. So, in analyzing those foods people took on my birthday party, okay, those that have stomach upset and those that don't have stomach upset, you might realize in a case control, I'm just giving a hypothesis that indeed they got the disease from my birthday party. You might realize that those that are cases, the cases have one risk factor which is in common. Maybe the people that ate kalo, mostly more people that ate kalo are the ones that are having stomach upset. So when you do your analysis around there and then do your regression analysis, okay, your logistic regression analysis, you may realize that, oh, indeed, people who ate kalo are the most, are the ones that were at high risk of developing stomach upset, okay? So that is how a case control could be, or how it is designed. But however, usually the case controls, the association could be there, but they don't prove it. They don't suggest causal, and the association is not so much proven. Because these people ate a lot of things. How can you really prove that kalo, and yet some other people also still ate kalo and they didn't get the disease? So they don't really prove that association, or the causal is not proven, cannot be proven, right? So we have what we call the nested case controls. So a nested case control, you'll hear about them in the future as you do your research. The cases and the controls are drawn from the population, okay? And this population is actually a cohort that has already been, maybe some research has already been done onto it, okay? So controls are also at risk of developing the disease. Let me give you an example of when you're studying smoking and development of TB, okay? So you follow these participants, those that smoke and those that don't smoke, you follow them forward in time, and then you realize that, oh, at maybe 5 years, some are developing TB and some are not developing TB, okay? So you go in that cohort that you already know that has not developed maybe TB, then you consider those ones as your controls, okay? Or you go to those that smoke, because they're also at risk. Those that smoke and are at risk, you study them, those that develop TB and those that haven't developed TB, but they are smoking. So you realize that in that cohort, the controls you are using are also at risk of developing tuberculosis. I'm going to repeat it another time. Nested case controls, it starts like a cohort. You're following up persons who are smoking, and you see whether they develop TB. Future in time, some develop TB and some are not developing TB. In the two groups, okay? Now you concentrate on the group of those who are smoking. Still, there are those who are smoking and they're not developing TB. So you study that group, where those that haven't developed TB but they're smoking, you consider them as your controls, and the others that developed TB, you consider them as your cases. I hope that is now right. Okay. So for case cohort, that is another study. So the controls are drawn from the same cohort in the cases, regardless of their disease status. So still in that same manner, whereby you have a cohort, so you can go and just pick the cases from a group of those who have TB, whether they have TB or don't have TB, you study them, okay? You study them because we study the disease of interest in that group, okay? So that is what we call the case cohort. Controls are drawn from the same cohort at the case and the cases regardless of their disease status. Okay, I hope we are clear on that. Then let's also look at the cohort studies. So cohort studies are also studies called maybe they study outcomes and they also study incidences because they are they are most of the cohort studies are prospective and they can give you the number of new cases as you go on with these studies. Cases keep on coming. Okay, so and I told you earlier on that incidence is the number of new cases. So for cohort studies, more majorly prospective cohort studies, they are incidence studies. And as the image is showing you down here, for cohort studies, you compare two groups, those that are exposed and those that aren't exposed, those that are smoking and those that are not smoking. You follow them forward in time to see whether they develop TB. That is a cohort study. So I have this image here. So despite of inferring association to studies, you must, after the observation of the association, the next question that has to be coming into your mind is this association causal? Can you prove to us that what you've realized that smoking and TB, there is an association? However, can you prove to us that this association is causal, that if you smoke, you get TB? So that is what we mean whenever you get uh, uh, results where there is an association. The next question that has to come into your mind is to whether this is causal. So that one is still another tense research that you need to do to come up with that kind of answer. So this is a case. This diagram here represents the prospective cohort, and also the case control. And this shall be discussed later on when we switch. So the question that we have at hand here that you are going to answer when we switch is, you look at these images. We have image A, B, and C, and you are going to tell me the study design basing on these images. So we have past, we have the present. But to give you an explanation is, in the first case, or A, the researcher is at the end, is on your right side. I hope right is right also that side. Is on the right side. And in the present, he wants to study those who are diseased. No, he gets those who are diseased and those who are non-diseased. So that is, and then he wants to study the exposure, the risk factors. So at present time right now, there are those who have a disease and those who don't have the disease. And he wants to study them to know the risk factors. Then in scenario B, the researcher is in the middle there, okay? There is already people under the arm of exposure and those who are not exposed, okay? Maybe smoking and non-smoking, or maybe malnutrition and well-nourished. And then the researcher wants to study the disease that they will develop in the future. So that is B. So for C, the researcher is at the end. He doesn't know the disease, but he wants, there is, in the past, the people were exposed, the participants were exposed, and there are some that weren't exposed, okay? And the researcher wants to know the disease at present time, okay? So those are the presentations right now that you have to identify the study designs, and then you'll answer, okay? So I think we are going to switch to the other session, and then